lecture. So again, if you like to increase your midterm score, you can try to do it again over weekend and just email it to me. And this way I will be able to increase your grade. I never mind if students get some extra credit if you're willing to work a little more. Just let me know if that's the case. But of course, to those students that never sent me any work, well, they should do this because I don't have a way to put a grade on Canvas if there is no midterm, there is no homework, then what kind of grade should I put? Failing grade? I don't want to put those failing grades. I just have nothing there. But again, I'm waiting for your work if you did not submit it. So submit it. I wrote this also on Canvas, so to give you a chance to do this. Anyways, if something is unclear, you can always ask if you're not sure. Again, I email the recordings of lectures, the review before the midterm. Well, look at the last week lecture recordings. It's all there. It's all there. So anyways, I guess we're gonna start with section 3 of chapter 7. And if someone wants to talk more about whatever things related to midterm or anything else, well, just let me know. Don't hesitate, because if you don't talk to me, how do I know that you're facing some kind of issue or whatever? So just let me know if anything is on your mind. So anyways, I'm going to move to section 7.3. I guess we spent already plenty of time with this arc functions, and now we're going to solve so-called equations. If you remember, in the algebra classes, we had equations to solve, and those equations had solutions completely different with exercises that you need to simplify. Because in the equations, you find what your unknown letter x is. So I guess a good example is 3 here. So we're now in the section 3 of chapter 7. And here we trying to solve equation. And when you do that, you're gonna isolate your sine function. So you just bring that square root 3 over to the other side. So they're actually doing a good job solving this, and they end up with something like that. So now comes the key question. How can I possibly find angle theta if sine of theta is equal to negative square root 3 over 2? And what happens then? Again, my favorite unit circle comes into play. So sine is y coordinate. So if I find point with y coordinate equal to square root 3 over 2, then one can say angle theta then is going to be equal to 5 pi over 3, right? But not only that. It turns out that angle theta can also be here, which is 4 pi over 3. And you can see this from symmetric picture of our unit circle. It's symmetric through y-axis. So if you have value of sine or y coordinate equal to this particular number, square root 3 over 2, which is very, very close to 1 with a negative sign, then there are 2 points on the unit circle that correspond to it. But not only those. if you will rotate this all the way around, in other words, if you add 2 pi, or if you rotate it twice around, you'll still end up at that same point. So you can rotate it as many times as you like, and that's why they say 2 pi times k, where k could be any integer number. So it could be 0. If k is 0, then you just have that 5 pi over 3. Or if it's 1, then you add 2 pi. If it's 2, you'll add 2 pi and then again 2 pi. But you can go the opposite direction. So it'll be negative 1 pi, negative 1 times 2 pi, or negative 2, etc. And the same thing will be with the other solution. So this is something that comes automatically because, again, period of function that we work with, and this function here is a sine, is equal to 2 pi. In this exercise, they actually say use only solutions that on the interval from 0 to 2 pi. So they don't ask for those. But those are very important, and you will be able to see it in the later exercises. Why? Like later exercise number 4 is actually the one that I want to consider after this. So issue appears because we don't have a clean sine of theta, but because it's a sine of 2 times theta. And why this is going to be an issue? Well, let's take a look at the solutions. So we already know that if we have a sine of angle equal to 1/2, then sine is somewhere here, point on the y-axis, which is equal to 1 over 2. And then there'll be 2 corresponding angles to it. So just like in the previous exercise, I can say that now it's 2 theta, right? Could be either this angle here, and this angle is little one, or 30 degrees. I can say it's pi over 6. Or if you like, you can deal with degrees, it's up to you. And then automatically I'll put 2 pi times k. Because again, function sine has period 2 pi. So that's for the first one. But there is another one. There is a second solution, which is on the other side, which is here, put it in red. And that angle also has something to do with pi over 6 if you go from 180, but it is not really pi over 6. It's going to be measured actually 1, 2, 3, 4, 5 of these pi's over 6. And again, automatically I add 2 pi k. So this is very important for this problem because now we need to pull out our theta. To pull out theta, I'm going to take a half of 2k. So I put times 1/2 here, and then also times 1/2 the other piece. So this 2.5 will disappear, and let me write what my theta is going to be equal to. Notice that angle theta is going to be pi over 12 because 2 goes in denominator like a half, plus pi times k. See, your period changed. Let me write k a little bit nicer. So period changed, which means that we're going to pick up more solutions. we'll see that. So I guess I should have probably put this next to it. So that one, I'll also divide by 2, so I get a theta out, and when I take 2 and put it in denominator, notice if you divide by 2, it's convenient to just put that 2 in denominator, right? Or with fraction multiplied by half. So you're going to end up with 5 pi divided by 12, and also plus pi times k. So this way, I'm going to have my solutions that I'm going to put on the unit circle to show you better what is actually going on, what the solutions mean in here. So I'm going to be taking the circle and try to make a nice and symmetric picture. That's, I guess, important for this problem. So it looks like that for the first one, excuse me, for my first set of solutions, I have pi over 12. So pi over 12 is a little piece in here, but since the period now is pi, there'll be another one here in the circle on the other side. You see that? So how can I describe that other one? Well, notice that this is pi. So half rotation is same as a pi, right? So if I go all the way around, like half pi. But I could also treat it as 12s pi. Why? Well, because I'm dealing here with 12s, right? So I want to add another 1/12 of pi, so it'll be 13 of this 12s, you see? 13/12 pi. So that way I produce like 2 opposite points. So actually, because of this 2 thetas, we picking up another solution. That's the message. And then, well, then we also have a second one that deals with 5 of this pi's over 12. So how can I put 5 of them? Well, if I divide pi by 12, so that'd be a half, which is pi over 2, or I could say it's 6 pi's over 12, right? So if you get 5, then it'd be a little bit less. So 5 pi over 12 is somewhere here in the first quadrant, people say. And then if you go with a half rotation, because we're again adding pi, so this will give us another point here. So how many those 12s will be there? Well, it looks like you just add 5 and another pi, which is 12 pi over 12, right? You can always write this with same numerator and same denominator. So if they cancel, you just get pi, which is what we have here, like half rotation right across the center. Right? So when I add 12 and 5, it's going to be 17 of these pi's over 12. See, that's how I got another. See, this section also has its own specific here, and that's actually what they're trying to discuss in the example 4. So I believe if you make pictures and if you can see your solutions on this picture, it's nice and symmetric, and that will definitely enable you to actually visualize these 4 special points that they are discussing here. But in my opinion, it's much better to just leave those general solutions, this one as well as that one, because there are more. It's not just in the interval from 0 to 2 pi, but we described all of them. So from that one, you can rotate by pi, and then you can rotate by pi again, you get another solution, and then you could also rotate the negative direction. And that's why this k is always going to be, people say, element of integers. Again, it's 0, 1, 2, 3, dot, dot, dot. Same on the other side. -1, -2, -3, -4. So instead of writing all that, people say it is element of integers. If you ever saw this before, that's a short way to write these possibilities, like 2, 3, 4, 5, so this integer numbers. So I guess our goal for today will be to practice solving some more of these equations. And the difference is there are infinitely many solutions for each of them. But all you need is basically to, I would say, make a picture. So that when you made a picture, like I just did here, then the intuition comes. So you can better see what is actually happening. So let me try another one with the sines and cosines. Maybe I can do problem number 15 that has a square for a change. So let me see how we can do 15. And again, our goal is to isolate function sine that appears here. So you have 2 sine squared of angle theta minus 1 is equal to 0. So we solve it as we always solve our equations. So I'm going to write this equal to 1. And then when I isolate my sine, I get a half for the sine squared. And then people extract the square root on both sides. And when you do this, plus minus appear. You say, Alex, why is plus and minus going to appear? Well, that's what we discussed in the college algebra class, which is a first half of this course. Let me give you an idea why it's a plus and a minus, because I think it's interesting to know when you square root something why it's plus and a minus. With something more intuitive, let's say x squared is equal to 4. If you have equation that looks like that. Then what's for x? We say, well, 2 squared is 4. That's correct, but also -2 squared. You see that? So people say whenever you extract square root on both sides of your equation, one answer is with a plus and the other answer is always with a minus. You could solve this various ways. You could bring 4 to the other side and factor it. That's how sometimes people do it. But no matter which way you go, there will always be 2 solutions, one with a plus, the other with a minus. And that's why I put this plus and a minus. So I'm going to end up with a sine theta equals to something more familiar will be square root 2 over 2. Because you can always turn this fraction into square root 2 over 2 if you multiply it by square root the top and the bottom. So your denominator has square root 2 times square root 2, which is just a 2. And numerator now is going to have a square root. So the point of story is that you can find theta that will be dealing with an angle of 45 degrees, right? So it'll be, now I should be a little bit more careful. So I don't want to solve this without a picture, because otherwise I might get in trouble. So let me make another nice unit circle. And then you will see right away what solutions are. Eventually, after you do number of these exercises, you will get this circle automatically without making a picture, it be in your head. But I don't think we need to do that. We need to do it right. So if we learn how to do it slowly and correctly, then you can do it faster. So if you get a unit circle, again, if you recall that sine is value on the y-axis, right? Square root 2 over 2. Excuse me, what's going on? Looks like I got. Anyway, so negative square root 2 over 2. They correspond, we already saw, to popular 45 degrees angle. But there'll be another 45 degrees angle here, right? And notice that there'll be two more of them. So there'll be actually 4 angles here, such as a pi over 4, then 3 of those pi's over 4. So we get odd number of pi's divided by 4. 5 pi over 4, and finally 7 pi over 4. So if you look at the picture, then right away you can give them the answer in the interval from 0 to 2 pi. But what I'm also interested in, how to describe the solutions using just one equation. Please notice that if you start with pi over 4, and if you rotate by 90 degrees, you will get the other. And then you rotate by another 90 degrees, you get another one. So if I add 90 degrees or pi over 2 number of times, k times. So it means either add or subtract, you get the new answer. And I think that's pretty nice and symmetric picture to consider and very neat to have. And I guess I can do another little exercise for you for more practice. I don't think you need a quiz today. You just had a big exam, right? So I'll just do one more and let you go without a quiz. Let me do 31. So it looks like these exercises, they start to get more and more involved. So again, today I just want to deal with sines and cosines. And next time I will solve other problems. There's like secant, tangent, so we'll do those next time. So for 31, we have to isolate whatever deals with our angle. So if that's whatever 2 thetas minus pi over 2, fine. I have that here, and it's equal to -1. In other words, they asking me, say, Alex, if you have a cosine is x coordinate equal to -1, then what kind of angle this is gonna correspond to? You say, well, this is 180 degrees. In other words, it's pi. And that's great to observe. So my parentheses, there's 2 thetas minus pi over 2, because I got rid of cosine, will correspond to pi. Sorry, why did I put pi over 2? I said pi and I wrote pi over 2. Pi. So we have something that we can pull out our theta from, but since it's a cosine, remember, automatically we add the period to pi k. That's absolutely must do. Well, and then I guess I need to start isolating our angle theta because we want to solve this for theta. So I'm going to be getting theta. So let's finish up with this. And of course, I'm going to make a picture of this solutions again. So it looks like I have to take that pi over 2 and add it on both sides, right? To isolate theta. First of all, I need to take away this pi over 2, so I'm going to add it with a pi. So what's going to happen then? Well, 2 thetas will be equal to 3 pi's over 2. Again, this arithmetic is pretty standard, and I guess you should get used to it, because in every exercise you will have to do it, pretty much in every exercise. So first of all, you see denominator of 2. Since of pi, you put 2 over 2 pi's, and then you add 2 and 1, and that's how you get 3 of these pi's over 2. And of course, I'll keep that 2 pi k the way it is so far, because now I'm going to divide, right? Divide, or people say times it by 1/2, because when you deal with a fraction, we already know that it's convenient to put a fraction next to it. So we found what theta is, and this is going to be 3/4 pi. Whatever it is, it doesn't matter to me. I just write it. And plus pi k, right? So this 2 and 2 cancel. And that's great. So now I can make a picture to see what is actually going on. And I would say making this picture is essential for solving these exercises, because right away you get what's on that circle from 0 to 2 pi. So 3/4 of pi, it's here, right? We just saw this in the previous exercise on that circle as well, right? So here's 1/4, it's 3/4. But now I have to rotate it only by half rotation. So I'm going to hit 7 of these quarters of pi. You see the 2 points that belong to the interval from 0 to 2 pi. So I think it's enough if you marked those like that, but of course I'm going to keep that period, because in the next sections we'll have to have period, and looks like in this section we also must have that period, because without it we wouldn't get the second answer, you see, because of that period divided by 2 that gave us pi, and that's how I produced that second answer. And that's why I think it's important to include this period in the story. So I would say it's enough, and I'll let you go with no quiz. And to those students that not happy with their grade, somebody can say, Alex, I got a C, that's all I want. Well, you can get a B, I don't mind. Just give you a chance. I have time to grade extra work. So if you want, you can always email it to me anytime on the weekend. I'm checking my emails, so no problem. So I guess I'm gonna stop this recording and see if you have any questions.